Okay, so so the purpose of this video is just to give you some clarifications about lab number 3. Okay, so let me maximize this one here first. Yeah. Oops. I just made some slides here. Okay. We cancel the speaker. Okay. So one of the chips you are gonna use in this lab is 7400. Okay. As I'm gonna explain later, 7400 is a family. Okay. This family has different chips, and the chips have different gates. So let's first talk about 7400. Let me just make sure. Yeah. So as you see here in this figure, you can see this chip has 4 NOR gates. Sorry, NAND gates. Okay. In last lecture, I explained NAND gates. I told you NAND gates is actually AND gate and then followed by inverter. Okay. So as you see here in this chip in 7400, you have to connect pin number 14. I think at this moment, you should be able to number the pins. Okay, as I told you before, when you see something like this one here, or you see a dot, so that means you have to number the pins this way. Okay, so this is the beginning, number 1, 2, 3 until 7, and then 8, 9 until 14. Pin number 14, you have to connect it to 5 volt. Pin number 7, you have to connect it to 0 all the time. And then after that, you have here four gates, four NAND gates. So for example, if I want to use this one, so I can use these two pins as input, and I take the output from here. If I want to use this one, input and output, and so on. Okay. The other thing here, yeah, this is just the truth table for NAND and NOR. I think I already explained it in the last lecture. Yeah, maybe you are confused when you see something like that because, but I'm gonna explain it. It's just very simple. So as I told you before, the way this NAND works is, so if you look at the truth table here, the only way to get zero is when the two inputs are 1 and 1. Okay, simply because when the two inputs are 1 and 1, the AND is gonna output 1, and then the inverter is gonna make it 0. Any other inputs, you are going to get here 0, okay? And then you are going to get 1. That's why you see always we get 1, except only when the two inputs are 1s, okay? As I told you before, there is an electronic circuit, but we're not going to teach it in this course. For sure, this is other courses will focus on that, but there is an electronic circuit that we can use to do this functionality, to do this table. Okay, so here I just give you some idea about this one. Okay, is about it. Every time you see something like that, so this is transistor, and I'm gonna make, for sure you are gonna take it in electronics, you will understand better. But for the purpose of this course, okay, you can see this transistor simply as a switch, right? So you can see it is like a switch. This switch has two position or two cases. Either it is open, like this case, this is open, or the switch can be closed, short circuit. So either it makes open circuit or short circuit. Very simple. If the input is 5 volt, so if you input logic 1, which is 5 volt, so actually you connect it. It makes a short circuit. Is that okay? If you put 0 volt, so actually you open the switch. So you can see this. So here we have two, right? So we have two switches here. So again, I'm not expecting you understand it, but at least for the purpose of this course, so the main idea here, this small circuit can actually do the NAND. Just I want to link somehow the electronics with digital system. So this circuit here actually is doing NAND. You know how? I'm going to tell you how. Look, very simple. Here, the only way to get 0 volt here, okay, is when there is a short circuit there, this way, okay? Because we here start to 5 volt, we have a resistor, so current has to go this way. So the only way to get 0 volt here is actually when the two transistors are short circuit or connected. And the only way to connect them, both of them together, is to have here 5 volt and 5 volt, which is 1 and 1. So the only way to get 0 volt here is when the two inputs are 5 volt and 5 volt, or logic 1 and logic 1. Any other case, for example, if we have 0 volt, so this transistor is open circuit, okay? So here, there is a very little current or no current from here, so the output here is going to be 5 volt, okay? The other case here is if this one is 1, so actually still we need a path in order to get 0 volt here. Both of them have to be connected. If one of them is connected, the other one is not connected, so actually there is no current going this way. So the voltage here will be 5 volt, okay? Anyway, so this is just a simple idea, just to explain to you. Again, don't worry too much about electronics. It's not the purpose of this course, but I want you to understand there is electronic behind it. And you can gain some little information about these electronics because you are going to get details in other classes, okay? So here in this lab, what I want to tell you here in this figure is, you are familiar. Sometimes we use a bubble like this one in the input. So what this means, what this bubble means. Always, guys, this bubble means not inverter, okay? So when I told you if I have AND, if I have AND, and then after it I put inverter, okay, that's what we call NAND, right? The way we draw this NAND is just to put bubble here, this way. Same thing, I can do it at the input. So if I do here at the input, so actually here, the input here is actually A prime. Okay, because we have here A, and this inverter will make it A prime. So the output here should be A prime and B. Okay, let's agree on this. The other thing here I'm teaching in figure number 5 is, if we, and also I think also explain this one in the lecture, one of the reason we need NAND and NOR, because using NAND and NOR you can you can make the 3 basic gates, okay, and or inverter. These are the 3 basic ones, okay? You can do anything using these 3. So I told you last time, if this is NAND, and then if you put inverter after it, so you can get AND, okay? And in order to get inverter here using NAND, so actually this is inverter. You can just tie the input here. So what I want to say, what I want to tell you guys, any logic circuit, okay? Let me summarize what I said, make it very easy. Number 1, any logic circuit, okay, can be designed, can be implemented using these main operations here. Is that okay? Also, these 3 operations can be implemented using NAND. So in other words, any logic circuit can be implemented using only NAND. That's why if you have a nice, same thing for NOR, by the way, same thing for NOR. That's why if you have a nice electronic circuit for NAND, I can use this circuit to implement everything. So everything will be NAND, okay? Because simply in this NAND, I can make it easily AND. It can do AND, it can do OR, it can do inverter as well. In case of inverter, as I told you here, you just tie the input. In case of AND, you just put here two NANDs this way. So this one like an inverter. Okay? One of the things you have to do here in this lab, let's look at this one here, this logic circuit here. Very simple. Look here, guys. As I told you in the lecture, this is NOR. So And because I put inverter here, this inverter is gonna cancel this one. So these two together, it becomes OR. You got what I'm saying? So if you have an OR this way, okay, and then I put inverter, so this inverter is gonna cancel this inverter, okay? Because as you know, the NOR itself is actually OR, and there is one inverter after it. And then if you add another inverter, so this inverter is gonna cancel this one, okay? So what I did here, what happens here in this circuit, these two together is actually OR. And these two together is actually AND. These two together is actually AND. Is that okay? So if you see here, and that's what I explained in the lectures about function, about truth table, and so on. So if you have here A and B, so here actually A and B, and here actually B and C. And then at the output here, I'm gonna get A and B or B and C, okay? And this is the truth table for it. So I want you to like practice. You can try here these cases, case by case here. You can try it and put it here and see if the output is equal to this one or not. Should be equal for sure, okay? So one of the things here, if I want to implement this circuit using gates, okay, using chips, so usually we would do something like here, what you see in figure number 8, okay? So as you see here, for example, here I'm gonna say, here in this figure, I need two NAND, I need two inverters, I need three inverter and one NOR, okay? So I decided to use three chips, okay? So, and these chips are part of the family of 74, okay? I want to tell you something important, guys. I know there may be some information you need to search, or you can find it. That's why you have to pay attention to hyperlinks. So here in the lab, I put hyperlinks. You can click on these links and you can find the information you need to know. But it's very simple. So what I'm saying here, we have a family. It's called 74. Okay. So this family has several numbers. For example, 7400 or whatever, several numbers under this family. And every chip here has different. So for example, here 7400. So this is here a chip number 1, and this I'm going to use it here. Also, I'm going to use it here. That's why you can see here IC1, IC2. Okay, so because this chip actually has 4 or has NAND gates. Okay, also you need to look at the data sheet. You need to look at the diagram, like this one diagram here, in order to know, because you have 4. You need to decide which one you want to use, right? So for example, I can use bin number 1, bin number 2 for input, and the output can be bin number 3. And I think that's what I did here. Look here, 1, 2, and 3. Okay. So here, when I say IC1 means I'm going to use chip number 1 here, chip number 1 here, and I define chip number 1 here. What I mean by chip number 1, this is a bin number 1, bin number 2, and this is bin number 3. How can you come up with the bin number? Very simple. As I told you here, you need to find this diagram like this one, and then you have here 1 and 2, and then 3. You can ask me why use this one. Why didn't you use this one? Okay, it doesn't matter. I can use any one of them. They are the same. For some reason, I selected this one. I can also take any one of them should be okay. Okay, because I need 2 of them. That's why one chip should be enough, because I need only 2. The chip has 4, so I can use 2, and okay, I'm not going to use the other 2. Anyway, so same thing here. Input is 4, pin number 4, pin number 5. The output is number 6. Okay, so this is for the inverter. Now let's look at the inverters here. Okay, sorry, this is for the NAND. Now let's look at the inverter. So the inverter here is actually IC number 3, as you see it. This is one IC number 3. And if you look at the diagram, I don't know how many ones inside this one, but I think it has more than 4. I think I had one figure before about this one, but you can check the data sheet and see how many we have. Okay, and then also the same thing. I think if you just want to do it, let me do it now. Actually, I think I put it before. Okay, let me go. Yeah, look here. Yeah, this one here. Look here. Yeah. So here again, you have to connect this one to 5 volt. You have to connect this one to ground, and then you can use. You have 1, 2, 3, 4, 5, 6. You have 6 of them. So I can use this input, output, input, output, input, output, and so on. Okay. So And by the way, you have other chips. So here, that's why you need to look at, you have other chips. So here we have a chip, this one, 74 as well. This one has 4 NOR, 4 OR. This one has 4 NAND. This is what we have. This one has 4 exclusive OR. That's what I explained last time. This one has here NOR. This one here, different numbers, the same family, but different number, okay? So here, these are NAND. Anyway, so let me come to the point here. Okay. Yeah. Okay. So here it's IC3. I'm gonna, so here this is pin number 3, pin number 2, pin number 7. So if you can make a diagram, this one connection would be very easy. Okay. This detailed wiring diagram. Same thing here. I'm gonna use NOR. In NOR here, I'm gonna use IC, this one here, 7402. Okay. And here, this one is gonna connect it to pin number 2, pin number 3. This is pin number 1. One of the things also I explained last time, exclusive OR. I explained it last time. I told you in exclusive OR, if the 2 inputs are equal, 0, 0, or 1, 1, I'm going to get 0. If they are different, I'm going to get 1. That's what I explained. This is the symbol here. There are some chips that have exclusive OR, okay, as a gate. Also, I think what you have to do in this lab is you need to create this exclusive OR using the basic basic gates. So in this case, as I explained in the lecture, Y here should equal AB prime or BA prime. Okay. So, and this is exactly what this circuit is doing. So what this circuit is doing is, as you see here, as I told you, this is AND, because it's NAND followed by NOT. Okay. This is another AND. And this is OR. That's okay. So here we have 1 OR and we have 2 AND. Okay. So here I have to input. As you see here, I'm going to input here A and B prime. And then here I'm going to input A prime and B. Okay. So that's why you are going to get this one. So actually what you have, what I'm doing here in this figure number 9 is I'm implementing exclusive OR using the basic operations here. Okay. So you need to do this one and then you need to test it. You need to test the truth table. You need to see if the truth table, if this circuit will give you the same truth table here. If you input 0, 0, I'm going to get 0 or not. If you input 1, 1, I'm going to get 0 and so on. Okay. One important thing here also, you will do, I think in this lab, in the coming labs as well, is in order to visually see the output, so you have to connect the output here to what we call an LED. This is the symbol. This is the symbol of the LED. So this LED, you can turn it on and off. Okay. So you can design you can design it so that when the output here high, 5 volt or logic 1, this one is on. Okay. When the output is 0 volt or logic 0, this one is actually 0. Is that okay? So, sorry, this one is off. So you can visually know what is the logic, is it 0 or 1, based on the status of the LED, is that on or off. Okay. So, this can make it easy to verify the truth table, because if I want to see the output, I don't need to measure voltage. I can just see it by using the LED. Okay. So one of the things you need to learn here, how you are going to connect LED. Okay. For sure, in electronics, you will get more details about LEDs, how they work, the details. But we need here, for the purpose of this lab, just you need to know how to use it. That's it. Okay. Same thing for the input here, because as you see, if I want to do the truth table, sometimes I want to input 0, I want to input 1, I want to input 0, I want to input 1. So if I'm going to show now, I'm going to use a switch in order to control the input here to be 0 or 1, as you will see here right now. So for example, if I connect, look, I can, this is a switch here. Again, this switch can help me to just input 0 or input 1 using switches. So what we want to do here in this lab, guys, is I want to connect the switches here in the input, and then by using these switches, you can actually input logic 0 or logic 1, and then you at the output here you connect an LED so that visually you can see if the result is 1 or 0. So let's look at when you connect these switches. Actually, you can connect it to one of two ways. So if you connect it this way, that's what we call pull up resistor. This one pull down resistor. Okay. So just two different approach. You can use any one of them. I'm going to tell you what is the difference quickly now. So here, let's look at this one first here. Okay. So if the switch is open, is open, that means you are inputting VCC, and VCC is 5 volts, so you are inputting 5 volt. Okay. So you know, any switch has two position. Okay. And two position. One position is going to give you 5 volt, and the other position is going to give you 0 volt. Is that okay? So what happens here, if the switch is open, you are going to get 5 volt. But if you connect the switch this way, you are going to get 0 volt. Okay. So this is one way to do it. The other way to do it, I can put the switch here and put the resistor here. That's what we call pull down. Okay. And in this case, let's see how it is different. In this case, if the switch is open, I'm going to get 0 volt, right? Because it's going to be similar to this volt here. But if the switch is connected, I'm going to get 5 volt. This is the main difference between, again, both of them are okay. Okay, you can use either one of them, but you need to be familiar with the term pull up and pull down resistor. And actually, I give you a link. So, for example, if you can see this one is highlighted here. So if you click on this one, you see a link. This link is explaining to you what you mean by pull up, what you mean by switch. Okay, if you need the information. So that's what you have to do in the lab. You have to connect the switches as the input here, and you have to connect LED. Okay, now when you connect how can you connect the LED? And the TE can actually help you on that. Okay, the LED is actually has two terminals, as you see here. One terminal here, we call it anode, and the other one is called cathode. So we have anode and cathode. Okay. You need to ask the TA which input is anode and which input is cathode. Okay. So, but an easy way, I think the one that is long. So usually, if you look at one is long and one is short. I don't remember if the long is a cathode or the opposite, but this is something that you can do or you can check. So this is how we can know which one is anode and which one is cathode, because it matters. In case of resistance, it doesn't matter. There is no, you can use this one or this, doesn't matter. But here, no, it matters. There is one, it's called anode, the other one is called cathode. And you need to know which one, because the connectivities will be different. Okay. One more thing here, if I want to turn the LED on, as we see here in this case, so this is, you can see this is F, because this is the output of the circuit. If you go back here, this is the output of the circuit here. Okay. So the output of the circuit is, as you see here. So one of the important things you should understand, you have to put here resistance. Why? If you don't put resistance, so this LED may burn out. Okay, be careful about it. Why? This resistance called current limiting resistor. Current limiting resistor. So the purpose of this resistor to reduce the current. Otherwise, the LED can burn out. Okay. So what happens here, as you see here in this figure here, and I forgot to tell you, if I want to turn, this is an LED here this way, this is anode and this is cathode. Okay. If I want to turn it on, if I want to turn the light on, so the voltage of the anode has to be greater than voltage of cathode. Okay. If otherwise, it's going to be off. Okay. Again, if I want to turn it on, the voltage of anode should be greater than the cathode. So if I connect it this way, if the output of the circuit is 5 volt, so the current is going to go this way, and then this one is going to turn on. Okay, because again, the voltage at the anode here is greater than the voltage at the cathode. Okay, but if the output of the circuit is 0 volt, which is logic 0, so this one is simply off. Again, you need to ask the TA about two important things here. Very important things, please, guys. Number one, don't forget to connect the resistor. Very important, because otherwise you are going to burn it out. This resistor to limit the current. Okay, this is number one. Number two, you need to know, you have to connect it correctly. Okay, so best, for example, here in this figure, this is anode. Okay, let me. So this is anode and this is cathode. Okay, so it has to be this way. Okay, don't flip it. Okay, what happens if you flip it? Okay, if you flip it in this case, look here, be careful. If you flip it this case, so this one will be off all the time. Why? I'm going to tell you why. Because always the anode here is 0. And the other side here is 0 or 5 volts. So always, I told you, in order to turn it on, anode has to be greater than the cathode. Is that okay? So anyway, so what I'm saying here, you can connect it by one of two ways. One way is called current sourcing, as you see here. The other one is called current sinking. So let's see what do you mean. And remember, this is the chip is here, okay? So why this one is called the current sourcing? Simply because when the output 5 volt, the current is gonna come from the chip this way to turn it on, right? When it is 0 volt, so it's off, no current, and it's off, okay? That's why called sourcing because you are gonna take the power from the chip. The other one here is called sinking. Remember, the chip is here, the logic chip is here. Okay, so let's see how it works. If I put here 5 volt, LED is off because here is 5 volt. Again, I told you, in order for the LED to work, the anode has to be greater than the cathode, the voltage. Here it's 5 and 5. So here the logic is going to be the opposite. So let me put this way. If it is 5 volts, this one is off. Okay. If I put here 0 volt, and this one is 5 volts, the current is going to go this way and go inside the chip. That's why it's called sinking, because the chip is sinking the current. But here in sourcing, okay, so the chip is actually sourcing the current. So anyway, so what I'm telling you guys, there is 2 ways to connect it. Here, if you do it here, so actually logic 1, it means you turn it on. Logic 0, you turn it off. Here, the opposite. Logic 1, off. Logic 0 is on. Okay. You can, whatever you want, you can connect the way you like, okay? One of the things is also here in the lab, yeah, for sure you need to use, you can use the simulator. You can draw a circuit like this one in the simulator, okay? A circuit like this one, you can draw it in the simulator, and then the simulator can give you the truth table, okay? Yeah, so here, A or B inverter, and B or C inverted, everything is inverted, okay? So if I wanna implement this one, as you see here, is actually this is NOR, and this is another NOR, and then here is NAND, okay? Is NAND. So that's why I can implement it using 2 NORs and 1 NAND. Okay. Yeah, what I'm explaining here is, yeah, every time, for example, I'm telling you static input or output instrument, okay? So if you look this one, you can find the link. This link gives you guidance, what this one, how can you use it, and so on. So this is very important thing, guys, okay? When I posted the labs last week, these hyperlinks were missing because it happened when the Word file converted to PDF. But anyway, I corrected it, and now you can see the links. Okay. So part 1, now I'm going to talk about. So here I explained LEDs. Also, the TS can help you how to. You need to be patient. Because you learn too many things. For sure, the details are gonna become, but it should be easy. It's not that hard. I'm gonna talk about DIB switches, how it looks and how we're gonna use it and so on. So this one is called actually DIB switches. How it works is, okay, as we see here, we have here 1 pin. First of all, this one is 8. This figure here, it has 8 separate switches. So it's like you have 8 separate switches this way. Separate, okay? This way. That's exactly. So for example, this one is here. So we have 1 pin here and we have another pin here. Okay. So in one position, you are going to connect these 2 pins together. In another position, you are going to make open circuit. You understand what I'm saying? So we have 8 switches. For sure, you may not need all of them. Okay. Whatever you need, you don't need, they are separate. Okay. So you can use 1, you can use 2, whatever you use. You don't need to use the 8. But you should understand, everyone here is actually a separate switch. And this switch has 2 inputs, okay? One look here, we have a pin here, and then we have pin is at the other side here, okay, for each one of them. And then at one position, you can make it open circuit. At the second position, you can make it also short circuit, okay? Another thing also may be confusing you in this lab, we call it SIP resistance. If I go back here, I told you in order to connect, here, I told you here in order to connect the switch, you need resistance this way. Is that okay? So how can you use this switch? This is, you have this one here in your kit. It's called SIP resistor. Okay. How this one? So this one, as you see here in this figure, it's actually 8, as you see here, 8 resistors connected together this way, and then we have one pin here. Wait a second. Why it's complicated this way? It's not complicated. I'm gonna tell you the main idea. The main idea is that, for example, if I go back here, I told you you can connect it in one of two ways. That resistor here, first of all, one pin of the resistor always has to go to the switch, always. So one pin of the resistor always gonna go to the switch. The other pin of the resistor either go to ground or go to VCC. You got what I'm saying? That's exactly what happens here. So what happens here, guys? Look here. This is so here I connect all of them together, and then I put it here to pin number 1. So if you want to connect it to ground, so you put here ground. If you want to connect it to VCC or 5 volt, you can connect it 5 volt. So you can use any 2 different ways, as I told you. Okay. So you have 8 resistors. What happened? The 8 resistors, okay, all of them are connected to ground this way. Okay. And then the other sides here have to go to every switch. Okay. So the way you have to use it is, for example, first you need to decide, are you gonna connect the resistor to ground or VCC? And then you can put here VCC or you can put ground. Okay. I think there is a dot here to tell you which pin, as you see here, which pin is actually the common pin. Okay. And then after that, all what you have to do, because now you don't need to use all of them, as I told you. Okay. For example, here I have a resistor. If you look at this resistor is connected to VCC, and then you have a resistor, and then after that it has to go to the switch, this one. So I can take this one here, connected to the switch here. Okay. And then let's see, the other side of the switch is gonna go to ground. For example, if you put here, let me go back here. Just I'm trying to do this one here. Okay. So here, here this one is connected to VCC. So the idea here, or what may confuse you, because it's not only one resistor, multiple resistors. I can connect all of them to VCC, for example, and then I can use this resistance connected to a switch, and the other one can go to ground. So if you decide to do this way, it's the same thing, but here you have to connect one, the common one, because again, you don't have only one resistor, you have 8 resistors. So the common point you can connect to ground, the other one can go to switch. Okay. Let me see if I'm missing something here. Okay. So here, I think in the first part here, you have to set up DIP switches, also LEDs. You have to do NAND. Please put the, as I explained, the switches and the SIP resistors. Please the LED and the resistor. Again, this is very serious. You have to make sure to connect the resistance of LED. If you forget the resistance, LED may burn out. Okay, and then here you need to connect NAND. I think a NAND gate of 2 switches, and now you can test this. You can test if this is NAND or not. Okay, easily. How easily? Every switch in one position give you 0, the other position can you 1. So you can easily change the input of the circuit. Okay, for the output you can visually see the output, if the output is 1 or 0. Okay, I think in the second part here I ask you to implement this one using a 7400 series. So series here, it means it doesn't mean a chip number 7400, it's the exact chip. Okay, no, this is a series, so you can use more than one chip here. This is a series. This series, it has OR and, as I said before. Okay. Okay, let me go to the lab, because I think there is also one expression that may bother you in this lab. I think it's one of the questions. One of the question is, Okay, so if I have a logic this way, guys, uh, how many different inputs I can input here? Someone can tell me they are two. So I can put here 0 volt to mean logic 0. I can put here 5 volt for logic 1. Okay, that's true for sure. So if you put here 0 volt means logic 0. If you put 5 volt means logic 1. But there is another thing, by the way, we call it high impedance. Okay, there is something we call it high impedance. High, let me write it here. High impedance. So high impedance mainly means open circuit. Okay, so that means this input is not connected to anything. It's open circuit. By the way, so someone can ask me, so if I don't connect this one to anything, okay, the circuit here will take it like 0 or like 5 volt. Okay, it will act as if it is 0 or 5 volt. For sure, this is change. You need to read read the data sheet, okay? But if it is floating, the meaning of floating means it's not connected to anything, or high impedance, okay? So in this case, uh, in this case, it will be taken either 0 volt or 1 volt. Okay, it will be taken one of them. It depends on, sometimes it depends on how the chip is designed. Sometimes it's 0 volt, sometimes 1 volt. So you need to look at the data sheet. So I think one of the questions here is about how can you connect the switch. So what I explained here, just I want to clarify things. What I explained here, I connected the switch in such a way, in one position give me 5 volt and the other position give you 0 volt. Okay, what if for some reason I want to connect the switch to give me either 5 volt or high impedance? High impedance. High impedance means open circuit. Open circuit. Okay. I think the easy way to do it is, for example, here I can connect a switch. This is the gate is this way. I can connect the switch this way, and then I can put here 5 volt. So if I open the switch, it's gonna be floating, okay, or high impedance. If you connect it, it becomes 5 volt. Okay, same thing for 0 volt. I think that's what I remember. Let me see if I can. If look again to the lab to see if anything here I can clarify more. Again, that's what I told you. So look, if you look here, you can see. If you look here, you can see the link. I think that's all what I have. Anyway, if you have any questions, just let us know. It should be okay. Thanks.